Have you ever looked at a polished report or a slick dashboard and wondered where that data even comes from? Well, today we're going to pull back the curtain. We're going on the journey that every piece of data takes, from total chaos to crystal clear insight.
And this is pretty much where every data story begins. A raw file, a CSV, an export, and it is messy. You've got extra spaces where they shouldn't be, you've got weird formatting, maybe even typos. This is data in the wild, and it's our starting point. So here's the million-dollar question, right? How do we take this jumble of text and turn it into something we can actually trust and use to make decisions? Let's walk through it, step by step.
Okay, first things first. We have to get this data out of a flimsy file and into a proper, structured home where we can really start to work with it. And that home is a database.
You can think of this whole process like building a house for your data. First, you got to buy the land and get the permits. That's creating a schema. Then you have to design the floor plan, the rooms. That's our table. And finally, you get to move everything in. That's loading the data. So, step one, we need a dedicated space for our project. In SQL, we use the command create schema. You can think of this as creating a new folder for our cookies project. It just keeps everything nice and contained, separate from any other projects in the database. Next up, we draw the blueprint for our house. The create table command does exactly that. We're telling the database, okay, I'm going to have a column for the date, another for the salesman's name, one for the price. We define every column and exactly what kind of data is allowed in it. Is it text, a number, a date? You have to be specific. And it's moving day. A command like load data is the magic step. It grabs our messy CSV file and just pours all that data right into the perfectly structured table we just built. And just like that, our data is in its new home.
All right, so the data is organized. Now what? Well, now we need a way to talk to it, to ask it questions. And the language we use for that is SQL, the structured query language.
Let's start with the absolute most basic question you can ask. Hey, just show me everything you've got. In SQL, that looks like this. Select star from cookies.sales. That little asterisk is just a shortcut for all the columns. It's our first peek at the data, all settled into its new structure.
But we rarely want to see everything. Usually, we're looking for something specific. By adding a simple where clause, we can start filtering. It's like telling the database, show me everything, but only where the salesman is Jones. Suddenly, all the other noise disappears.
And we can keep building on that. Check this out. We add order by sales, DESC. And what does that do? It takes all of Jones's sales and sorts them from the highest number to the lowest. And bam! With one simple line of code, we've instantly found Jones's single best sales day. That's pretty cool.
But, looking at individual rows is only part of the story. What if you want a big picture summary? Let's ask a totally different kind of question, like what was the average temperature across all the days in our data?
For questions like that, SQL has these incredibly powerful tools called aggregate functions. A function like AVG, you guessed it, calculates the average. We just point it at the temperature column and it crunches all the numbers from every single row to give us one simple answer. It's so efficient. And there it is, 72.4. Think about that for a second. One simple query can scan through thousands, even millions of records and boil it all down to a single meaningful insight. That is the power of SQL.
Now, SQL is absolutely fantastic for asking questions and summarizing data, but for the really deep, tricky cleaning jobs, we need to bring in a more flexible, heavy-duty tool. So let's move on to the next stage of the journey and unleash the power of Python.
So why are we switching tools? Well, think of it like this. SQL is like a high-speed bullet train. It is incredibly fast and efficient for getting huge amounts of data from point A to point B. Python, on the other hand, is like an all-terrain vehicle. It can go off-road and handle really complex row-by-row cleaning tasks that SQL just wasn't built for.
And you might think connecting these two would be complicated, but it's not. It's actually incredibly elegant. Using a library in Python called Pandas, we can literally run a SQL query right from our code. With just one line, we can tell Python, go to the database, grab all the cookie sales data, and pull it into a handy table-like thing called a DataFrame.
Okay, the data is now loaded into Python. It's time to roll up our sleeves and start the deep clean. This is like a full diagnostic health check for our data, where we're going to fix all those little imperfections we noticed at the very beginning.
Remember this guy, our old friend, Jones?
with those annoying extra spaces on both sides? Now, that might seem like a small thing, but in a big dataset, if you have Jones and Jones and Jones, the computer sees them as 3 different people. It completely messes up your analysis.
Well, watch how beautifully Python handles this. There's a function called .strip. We just pointed at our salesman column, and like a digital pair of scissors, it snips off any leading or trailing spaces from every single name in that column. One line of code, problem solved for the entire dataset.
And that's just one part of the routine. A full-on Python cleaning script is systematic. It'll go through and remove rows that are completely empty, trim all the extra spaces like we just did, find and replace any crazy invalid values, and finally, drop any rows that are still missing crucial bits of info. So after all that, after getting the data into a database, asking it some questions, and running it through a deep cleaning routine in Python, its transformation is complete. The data is now clean, structured, and most importantly, trustworthy. It is officially ready for prime time. And the very last step is to save our hard work. With another simple command, to.csv, we take our perfectly clean data from Python and export it back out into a brand new, pristine CSV file. The journey's come full circle. We started with a messy CSV, and we end with a clean one. And this, right here, is why we do all of this. The whole point of the entire process, from messy file to clean table, is to get to this moment. You now have a solid foundation of truth you can build on. So the only question that's left is, what story are you going to tell with it?